Alright, so let's go over Python linked list. And take a look at this little image of a train. It's going to come in handy in about 20 seconds. Let's get started. What is a linked list? A linked list is a chain of nodes with an initial starting point called the head. Each node has their own data and place in memory, but are attached to each other using a variable that stores the location of the next node's memory location. So, like I said about 20 seconds ago, you can think of a train, right? So a train has, trolleys, right? All interconnected by a hook. The initial, trolley holds a person that's controlling the whole train. And like I said, they're all connected by a hook, a chain, and each trolley looks about the same. Like they all hold people, right? But what makes it unique is that each trolley can hold, there may be 3 people in one trolley, 2 people in another trolley, vice versa. And we can get to the next trolley by, using a door, or just walking over a bridge maybe. It's the same thing like a linked list. A linked list is, you have the initial node, which is the head, and we use that to traverse to the next trolley or the next node, right? So each node has data, right? It has an attribute called data. We can hold, integer, a string, whatever. And we have another attribute within the node that is, it can be called whatever, but usually it's called next, right? So next will hold the instance of the next node's memory location. And we can use that to traverse to the next node and the next node and the next node. But the initial starting point will be the head. The head will be, a node. And then that will point to another node and then point to another node. So think of a train, right? A train has the initial trolley, and then that could be, you can use that initial trolley to go to the next trolley and the next trolley. But it has to start at the first one. So to traverse a linked list, start from the head, right? To traverse a train, start from the head. So now we'll dive into the code and see how to create a linked list. Alright, so let's get started on the coding of a linked list. I already created a file called llist.py, and I'm using Visual Studio Code, but like I usually say, you can use whatever editor that you want to use. I just like VS Code. And let's create the blueprint for the node. And I actually just created a video on classes and objects in Python, so you guys can watch that. It's literally the video right before this. But yeah, let's make a blueprint for a node. So let's do class node, open that up. Let's create our initial attributes for the node. So we're just gonna do a def init. I'm just gonna use the autocomplete for VS Code really quick, and then pass in the attributes that we're going to create for this node. So the first attribute I'm going to create is self.data, and this is going to just hold the data that the user passes in to the node. And to make sure that I actually get that, I'm going to create another parameter, and I'm going to call that value, and I'm going to set that equal to none by default, because if a user doesn't provide a value in the parameter, then I'm just going to make sure that it's going to be none at least. So then we're going to assign that to the attribute. Then the next attribute that I'm going to create is the next attribute, which is going to hold the memory location for the next node, right? So I know we're going to create a linked list, which is just a chain of nodes. So this initial node is going to point to another node, and this next attribute will hold that. But for now, I'm going to make it none. Alright, so let's create a linked list blueprint. I'm just going to call this L list, and I'm going to open that up, and I'm going to also create an attribute for this linked list class, and I'm going to make that init really quick, and then in here I'm going to define a thing called head, right? So we talked about head, this is just going to be the initial point for the linked list. We have to know where to start, and this head attribute will help us know this is going to be the start of the linked list, and we can go on from here. And by default, I'm going to make this a type node, because I want to make sure that the user is passing specifically a node value, and I'm going to by default make that none. And then so now that we have that set up, this is like the bare bones linked list node setup. We can create a node, and we can actually assign a head to the linked list. So let's do that. So let's make an instance of linked list, and we can do that by creating a variable called whatever you want, but I'm going to call it llist, and I'm going to make that equal to llist. the actual instance, like I'm making an instance of this class. And now I'm going to assign the head attributes equal to an instance of a node, right? And like I said, we can pass in a parameter. Whether we pass in a parameter or not doesn't really matter, but I am going to pass in a parameter, and I'm going to make that equal to 1. So if we didn't, then the data would just be none, like I said here. But since I'm passing 1 here, data is going to be equal to 1, and by default next is automatically going to be none. So if I'm going to create another node, right? And I'm just going to call this node, and I'm going to make that equal to, actually no, we don't have to create a variable. That seems very counterintuitive. We could just do, now that we have like the head, we can do the instance of the linked list. We can do head, and I want to chain another node to this, right? So I'm just gonna do .next, right? Because I want to make sure that I have the next, like I'm pointing the next iteration of this head to another node. So I'm gonna make that equal to a new node, and I'm gonna assign that value of 2. So let me just back up a little bit, right? So we made a instance of a linked list, and we assigned the head, the starting point, to a node of value 1. That's going to be holding data that's storing 1. Then now I'm also taking that head, which we assigned above here, right? We're taking that next attribute that belongs to that initial node, and we're pointing it to a new node called or that holds the data of 2. So now we have one node that holds 1, and we have another node that's chained to 1 that holds the value of 2. So in total we have 2 nodes, right? And let's create a helper method in this linked list class so that we can see how these are connected. So I'm just going to make a method called print list, and we're going to have that print out what's inside of this linked list. So to do that, like I said, to traverse a linked list, we have to start at the head. So I'm going to create a variable called current, and I'm going to make that equal to self, which is just pretty much saying this current instance of linked list, I want to get that current instance head, right? I want to get the instance of head of this instance that we created here. And with that current head, we're going to traverse it. So I'm going to do while current. So pretty much while this variable is not none, while it didn't reach the end, I'm going to print out current.data. I'm going to print out whatever that node is, whatever that data that's within that node, I want to print that out. And I'm going to create a separator so that if there's more than one item, then I'm just going to put a comma and then some space. Then afterwards, since we're trained, right, we're going to the next trolley, we have to use current equal to current.next. We want to get to that next node. And if this current.next is a none, because remember, by default, when we created a node, right, we assigned the data to 2, but the next is, by default, is going to be none. So if we ever get to that last node and that next node is pointing to none, that means we reach the end, and that means that we can get out of this while loop, right? So let's see this in action. Let's do a list, print list, print list, save it, and let's do Python, and let's do that. So boom, it didn't do the separation that I wanted, but we are seeing the values that I expected. I'm seeing 1 and 2 because it's holding, it's first it's going to that initial head, because the first instance that we created was this node that has a data of 1, and then it's pointing to the next node, which is holding a value of 2. So when we get here, we're taking the initial head, and then while we have a value in the current variable, we're going to the next one, right? So we're going to print out the current data. We're going to make sure that current is holding the next iteration or the next node, and then come back into the loop and then see if there's actually a value in current. If there is, then print that value again, assign it to the next value. If we get back here and see that it's none, that means we're at the end, because by default, if it's not pointing to anything, that means it's none. So that is the bare bones linked list. And yeah, I mean, it's useful to chain data if need be. And I know it's used a lot in interviews, like how to traverse it, how to reverse it, and I'm gonna create tutorials on how to do that. But this is the very bare bones linked list tutorial. And in the next tutorial, I'm gonna show how you can remove data from the linked list. All right, so before creating that method to delete a node, let's actually create two methods to insert. So what I want to do is I want to create a method to insert from the beginning and make it a method to insert at the end. Because right now what we're doing is we're inserting, manually, but I just want to be able to call a function to insert a node. So let's do that. So let's do one method to actually, push a node in the beginning of the linked list really quick. So we'll do this as def, and let's call that push. And then we're just going to take an instance of self and the actual data that we want to push into the node, or place inside of the node. And let's call this node to hold the instance of a new node, and we're going to place the data as the data that we're inserting into the node. And what we got to do now is, since we're going to insert this at the beginning, right, this means that this is going to be the new head, right? So we're going to take the node, and you got to think of like a train, right? So if we wanted to make, if we want to add a head to a train, what we would do is we'll take that new node, we'll take that initial trolley or that new trolley and place it in front of the train, and now all we got to do is connect that new trolley to the old head, which is what we're going to do in this case, right? So we're going to take that new node, we're going to set the next equal to the current head. Pretty much we're placing it in the front. Now head is going to be the second node, or the second trolley, and this new node is going to be the first trolley, or the first node, which is going to be the head. And we got to do that as the instance of the head that belongs to the linked list. And now, to make sure that we always reference this new node as this head that's being stored by the linked list class, we gotta make sure that we're doing self.head is equal to this new node. So now we know that whenever we call self.head, is going to be referencing this node instead of like the old node. But now we know that if we do a node.next, we're going to be referencing the previous head. But now this current head is going to be equal to the new node. Hope that's not confusing. If it was, then I would kind of rewind a little bit and go over it, or even just look at this line. Now we're creating a new node. The next one is pointing to the current head. That means we're making it the beginning. And now we're making sure that when the user needs to reference the head, it's pointing to this new node that we just created. So yeah. So now let's actually make sure that we can place a node at the end. So let's do, I erased that by accident. All right, so let's create a method that's going to append a value to the end of the linked list. And we're going to call this def append end, and we're just going to have a reference to self, and we're going to have the data that we're going to need to hold or to store into the new node. We're going to create a node, and it's going to make it equal to the data that we're going to place inside of it, and then we're going to get the reference of the head. So we're going to make that current equal to self.head, because what we're going to do is we're going to iterate all the way to the end, and we're going to append that new node to the end. So it's going to kind of be like the print that we created before, where we want to check all the way until the point of getting to the end. But it's going to be a little bit unique because we don't want to get to the point that it's none. We want to get to the node right before it's none, right? Because if we get to the point where it's none doesn't have the attributes that we need to start chaining the nodes or chaining the trolleys. Like if we use the train as an example, we want to make sure that we actually get to an actual node which has the attributes that we need, like next, to point to the new node. So what we're gonna do is, instead of getting to that point where it might be none, we're gonna make sure that we get to the node right before it gets to none. So we're gonna make sure that we get the current to check. We have to make sure we check that the current.next is none, right? So if we know that the next one is gonna be none, then that means we can stop, right? And then since we know that the next one's gonna be none, we can assign the new node to that current value. So let's just iterate. Let's do current is equal to current.next. And if we ever get to the point that current.next is none, that means we're at that last node before it reaches to that none, before it reaches to the end. And since we know that the next one is going to be none, we could just assign current.next equal to the new node, which means we're attaching that new trolley, that new node, to the end of the linked list. But there also is a case that head, right? Head might actually be none, right? We don't have a head yet. So if self.head is none, then we'll just do self.head is equal to the node. Since we're already going to make this new node equal to the head, it's not even necessary to do the check here, but it is necessary to do it here, right? Since we already know that, okay, if head was none in this case, we'll just make, you know, this new node's next equal to none, which is fine. That means we got to the end of the linked list. But in this case, we got to make sure that, you know, the head is not none, because then we won't even be able to do this current.next, right? That would just cause an issue, because if we try to do none.next, that's going to break it. So we got to make sure that self.head is none. If it's none, then we just make the head equal to node, the new node, and we can return. But if not, if self.head is actually equal to a value, then we'll have to iterate through it and then assign the last values next equal to node to create that addition to the chain. Alright, so let's test these bad boys out and see if we're actually pushing, you know, the nodes properly, using these two methods that we just created. So let's erase these two right here, and let's do list dot, and let's do a push initially. That shouldn't break anything because, you know, it's making the new node into the head, and if the head is none, then it's just gonna make sure that the next value is gonna be none. So that shouldn't be an issue. So let's do that push, and then let's do a list, and let's do append to the end, and let's do 2, right? Actually, let's do another one. Append to the end, and let's just make it a weird number. Let's make it, I don't know, it's not really weird, it's just 7, right? So let's do list, and then let's print the list. And let's do Python 3 list. Boom. As expected. That's pretty awesome. I'm not gonna lie. So 1, 2, 7 is in the exact order that we expect. We push the 1 initially, and then we append it to the end 2, and if we append another value to the end, then it's gonna be, you know, to the end it's gonna be 7, so it's gonna be 1, 2, and 7. And we can also check if that push work with another value. So let's do push, and let's do 3. Let's make it weird, right? And then we'll print that again and see what happens. So let's clear this out and run it again, and boom, 3, 1, 2, and 7. So this actually inserts it to the beginning. It takes that new node, makes that head, the previous head, equal to the next, and then it makes the new node equal to the current head, and it just, you know, it changed it all together. So that's a linked list. So now that we have these 2 new methods, now we can actually, you know, try to remove these much easier. But, you know, this is much easier than having to manually do it each time. So I just thought that this would be more useful to create first. So now let's actually remove some nodes. So we created 2 methods to insert nodes into a linked list. We have push, which pushes data to the linked list from the beginning, and we have append to end, which adds a node to the end of the linked list. So now, since we're able to add, let's find a way to delete. So let's create a method called delete node, and let's take in a parameter of self and index. So what this delete node is going to do is you're going to pass in an index to this delete node method, and it's going to delete the node at that position. So say for instance we have 1, 2, 3, and 4, and you pass in an index of 0, it's going to delete the head. It's going to delete 1, and it's going to pretty much shift it to now point to 2, and 2 being the new head, and 3 and 4 being the rest of the linked list. So let's actually implement that. So first, let's take a variable called node and let's assign it to the head, because that's usually what we do, right? We have to traverse a linked list. We would have to get the instance of the head, and let's do a check, right? So if the index is equal to 0, we know that we're trying to remove the head. So all we got to do is just take that instance of the head right here and make it equal to node.next. So this pretty much takes the instance of the head and make it equal to the next value after the head, because this node is holding the old reference of the head. I want to take the node after that. But now we have to actually start iterating if it's not trying to remove, or if the user is not trying to remove the head, right? So we're going to create a for loop, and we're just going to put a little line just to let Python know that we're not going to use the index that is being returned by this for loop. We just want to iterate, and we're going to take that range and we're going to iterate by the index that the user passes, right? So if they pass in 6, we want to iterate through the 6 times. And what we're going to do is we're just going to iterate like we usually do. But in this scenario, I want to have a reference to the previous node. So I'm going to create a variable called previous, and I'm going to have node, just to hold the current reference of the node. And I'm going to equal to, or actually I'm just going to make that current. I think current makes it a little bit easier to understand because it's going to be the current node. And the previous is going to equal to current because as we go to the next node, right, that current node is going to be placed into previous, and current is going to now equal to current.next because it's going to equal to the next node. Whoops. VS Code additions. So now if the node is none, or if the current is none, that means we can just get out of there because we weren't able to find an index because we went out of range. Like there's no linked list with that index, so we can just get out of there. But if we actually finish the for loop and we actually get out of this, that means the previous.next can now equal to the current.next. And you're probably thinking, what is this guy talking about? Like current, previous, what? So what I'm going to do, I'm explaining like this. I'm going to create a comment right here, 1, 2, 3, and 4, right? So say for instance, the user passed in an index of 2. Just like in arrays, we had to subtract it by 1. So really, if the user passes in 1 to get the first index is going to be 0, and add by 1 from there. So say for instance, they want to remove 3, that index is going to be 2, right? So the reason why we're keeping reference of previous is because, look, if we ever get to the point that we're at 3, which is the index that the user specified, we have a reference to 2, which is the previous node. But if since we want to delete 3, we want to ignore this pretty much. We don't want to use this place in memory anymore to reference this node. So now the next for this previous node should now reference the one after 3. It should reference 4. So we know we're currently at 3, right? Current.next is going to reference 4. And the previous.next, before I used to reference 3, but now we wanted to reference 4. So how we do that? We take the previous next, and instead of pointing it to 3 like we did before, we're going to reference it to the next of the current node, which is 4. So now 2 is going to reference 4, and it's going to completely ignore 3, which makes it obsolete. Because when a linked list, to know what node to get to next, we have to have something that points to it in memory. And if none of the nodes in this linked list points to that node, that means it's obsolete, it's deleted. So now 2 is going to point to 4, and we should be good to go. Hope that made sense to you. You can also rewind, or you can leave a comment if you want a little bit more of an explanation. But I already created some methods here, so we can actually see this in action. So we know that we have 4 items in this linked list because we added 1, 2, 7, and 3. And I commented out this print list because I want to actually delete some stuff first before we print it out. So let's do that. So we're going to delete the first position, which is going to be 3 because we pushed 3 at the end. and the last position, which is going to be 7 because we appended 7 at the end. So we should expect to see 1 and 2. So let's save this. Let's run Python 3 and let's run list, and boom. Let's see. So what is the error? Current is referenced before. So maybe, yeah, because we use node here, we have no choice. So we could just do current. Let's just change it to current. Because I feel like that's easier to understand. And let's run it again. Let's do clear. And boom, 1 and 2, right? So if I wanted to delete, 2, all I got to do is decrement this by 1 again. And now it's going to take that second position. So it should delete 2. And run that again. Boom. So now it's going to be 1 and 7 that's available. So that is how you delete a node by index. And, this is how you create a linked list. It's very, very intuitive. And it's going to be in a lot of interviews. Obviously, you wouldn't have to, I don't expect you to have to create everything or all these methods by hand. But you should understand how you traverse, how you eventually would have to reverse, which I intend on doing a video afterwards. But you should understand how a linked list work and why it does what it does. So hope you guys enjoyed. Leave a like if you did like it, and subscribe if you want to see more.